In this example, we want to find the value of for all 6 trig functions of the angle beta that's given in this triangle. So when we look at the triangle, we see that the side lengths are given to us. We can see that one of the side lengths is 5, one of the side lengths is 13, and one of the side lengths is labeled A. And so we don't know what that side length is yet. And to use the right triangle trigonometry that we've studied so far to find the values of the 6 trig functions for angle beta, we need to know the length of the side labeled A. So let's quickly start by finding that value. So let's find the length of side A right there. And we can use Pythagoras to find A. Alright, so the Pythagorean theorem tells us that A squared plus 5 squared, the sum of the two shorter sides of the triangle, will equal the square of the long side, the hypotenuse. And so we can just go ahead and do this math to try to find out what A is. 13 squared turns out to be 169. And so now we can isolate A squared. Whoops. Subtracting 25 from both sides. It turns out that 169 minus 25 is 144, which just happens to be a perfect square. When we square root both sides, we see that A must be 12. So this side here is 12 units long. And now we have the length of all 3 sides of the triangle, so we should be able to find the values of the 6 trig functions for angle beta. So when we go and look at angle beta, beta is arguably in a kind of non-standard position in a sense. I mean, we've often put our angles kind of in this spot here. Beta's in a different spot in the triangle, so we've got to be careful there. We've got to go kind of stand in the triangle where beta is and look into the triangle from that perspective in order to determine which side length is opposite versus adjacent to angle beta. And it turns out that if you were standing there at angle beta looking into the triangle, this side the side length A is opposite. This is opposite of angle beta. Maybe I should get rid of these little notations there. And then, again, standing at angle beta, when we look into the triangle, the other side here, 5, is next to the angle beta, so we could call this the adjacent side. And always in our right triangle, the side opposite the right angle, this side here is always the hypotenuse. So we can label it that way. And now we're prepared to find the value of all 6 trig functions for angle beta. So, for example, we want to find the sine of angle beta. When we in our right triangle trig study, we've discovered that the sine value of an angle in a right triangle is always the side opposite the angle divided by the side the hypotenuse of the triangle. So that will give us 12 over 13. We want to find the cosine of angle beta. Cosine is the adjacent side over the hypotenuse. And the side adjacent to angle beta is side length 5 over the hypotenuse, which is 13. The tangent of angle beta is opposite over adjacent, and that's going to be 12 over 5. Now the other 3, cotangent, secant, and cosecant, are all just reciprocals of the 3 that we've just found. So cotangent is just the reciprocal of tangent. So we can take the fraction we just found for tangent and just flip it over. So we're just kind of stealing that value there, right above it. For secant, we know that secant is 1 over cosine. So we can just refer back to our cosine value, which was 5/13, and just flip that fraction over. Whoops, I was trying to do that in another color. And the cosecant value, and cosecant's the reciprocal of sine. And so we can just consult our sine value, which was 12/13, and therefore our cosecant value must be 13/12. Again, consulting our sine value. So we're able to find the value for all 6 trig functions for the angle beta.